Question 5. Solve the inequality modulus x squared minus 8x plus 6 is lesser than 6. First, let's look at the side note. From quadratic equation, we learned that when modulus of A is equal to B, A is equal to B, or A is equal to negative B. What about when the modulus is dealing with inequality? Here we have two cases. Case 1, modulus A is lesser than B, and case 2, modulus A is greater than B. For modulus A is lesser than B, we can write it into two inequality. A is less than B, negative A is less than B. For negative A is less than B, we divide both sides with a negative. We get A is greater than negative B. We draw a number line. We have negative B and B. From the first inequality, A is less than B. So we have this line. And from the second inequality, A is greater than negative B. We find the area where it satisfied both inequality. Hence, modulus A is lesser than B is the same as A is greater than negative B and lesser than B. For second case, modulus A is greater than B, we can write it into A is greater than B and negative A is greater than B. For negative A is greater than B, we can also write it as A is lesser than negative B when we divide both sides with a negative. We do the same thing as what we did for case 1. We draw a number line, negative B and B. A is greater than B for the first inequality, and also A is lesser than negative B. These two lines do not overlap each other. Therefore, to fulfill the condition for both inequality, we take this part. A is lesser than negative B and A is greater than B. Let's go back to our question. Modulus x squared minus 8x plus 6 is lesser than 6 is case 1. Because we are dealing with quadratic, I'm not going to combine both inequality into one, but separate them. We will get x squared minus 8x plus 6 is less than 6, and negative x squared minus 8x plus 6 is less than 6. We will solve the inequality one by one. Let's start with the one on the left side. We rearrange it. X squared minus 8x plus 6 minus 6 is lesser than 0. X squared minus 8x is lesser than 0. We factorize them. X bracket x minus 8 is less than 0. When x bracket x minus 8 is equal to 0, x is equal to 0 and also x is equal to 8. We sketch the graph. We have a positive x squared, so it is a smiling curve. It cuts the x-axis at 0 and 8. We are looking for the area where the inequality is lesser than 0, which means below the x-axis. For this inequality, the x is between 0 and 8. Now, let's solve for the second inequality. We divide both sides with negative. We get x squared minus 8x plus 6 is greater than negative 6. We rearrange it. X squared minus 8x plus 6 is greater than 0. Simplify it, x squared minus 8x plus 12 is greater than 0. Then we factorize the inequality. X squared can be separated into x and x. 12 can be separated into 1 and 12, 2 and 6, 3 and 4. Here, 2 and 6 will be the combination we are looking for. To get a negative 8, minus 2x minus 6x. And we need to check negative and negative, we will get a positive. When x minus 2, x minus 6 is equal to 0, x is 2, x is 6. We sketch the graph. We have a positive x squared, so the curve is a smiling curve, cut at 2 and 6. We are looking for the area where the inequality is greater than 0, which means the area above the x-axis. Hence, the range of values of x are x is lesser than 2, x is greater than 6. Lastly, we need to combine all the range of values of x that fulfill the condition. We draw a number line. We have 0, 2, 6, and 8. The first range is x is between 0 and 8. Second one, x is less than 2. And the last one, x is greater than 6. Since the lines overlap, we need to find the area where the lines are overlapping. Therefore, our final answer are x is between 0 and 2, and also x is between 6 and 8. You can check your answer by substituting x value into the inequality. Let's try x equal to 1. If we choose x equal to 1, it should fulfill the inequality. One square minus 8 times 1 plus 6 modulus is equal to 1 minus 8 plus 6, negative 1, which is 1. And 1 is less than 6. So, correct. Let's check with a false answer. We choose x equal to 5. X equal to 5 does not fall inside the range. Later, the answer should be greater than 6. Modulus 5 square minus 8 times 5 plus 6 is equal to 25 minus 40 plus 6 modulus of negative 9, which is a 9, and 9 is greater than 6. So it is a false answer. Therefore, we can conclude that our answer is correct. Last question, question 6. Find the range of values of x for which 5 over 6x squared minus 11x minus 35 is less than 0. 5 over 6x squared minus 11x minus 35 is lesser than 0. Let's look at the side note. 5 divided by something is lesser than 0. 5 is a positive value. In order to get a negative answer, lesser than 0 means a negative answer, a positive value must divide by a negative value. Then we will get an answer which is less than 0. In order to solve these questions, 6x squared minus 11x minus 35 must be a negative number, which means lesser than 0. We solve for this inequality to find the range of values of x. Let's factorize it. 6 can be 1 and 6 or 2 and 3. 35 can be 1 and 35 or 5 and 7. There are many combinations, so you can try and error. Here I will choose 2x and 3x and also 7 and 5. I will put the 7 here and the 5 here. Here we will get 21x and over here we will get 10x. We need to get a negative 11, so we need to minus 21x, add 10x. Minus 21x plus 10x. And don't forget to check negative, positive, we get a negative. When 2x minus 7, 3x plus 5 is equal to 0, x is equal to 7 over 2 and x is also equal to negative 5 over 3. We sketch the graph. We have a positive x squared, so it's a smiling curve. The curve cuts the x-axis at negative 5 over 3 and also 7 over 2. We are looking for the area where the inequality is lesser than 0, which means the area below the x-axis. Therefore, the range of values of x that satisfy the inequality is x is between negative 5 over 3 and 7 over 2. We can do some checking as well. Let's choose x equal to 0. X equal to 0 fall inside the range, so it should fulfill the condition which is lesser than 0. 5 divided by 6 times 0 squared minus 11 times 0 minus 35 equal to 5 over negative 35 negative 1 over 7, which is less than 0. We can check with a false answer as well. X equal to 5. 5 is definitely more than 7 over 2. If we substitute x with 5, the condition will not fulfill. 5 over 6, 5 squared minus 11, 5 minus 35 equal to 5 over 150 minus 55 minus 35, which is equal to 5 over 60 or 1 over 12. 1 over 12 is greater than 0, hence the condition is not fulfilled. We can conclude that our answer is correct. So that's it for our lessons today. Hope it will help you in understanding quadratic inequality better. In the next video, we will start a new subtopic, which is quadratic function. So see you again in the next video.